So good morning everyone, and welcome to the last day of DevWeek, unless of course you're sticking around for the boss conference. So I hope you had a good night's sleep, because this is a more advanced session, so it's going to be tough, it's going to be quick, it's going to have multiple topics. Actually they're not really related to each other, but they are required if you are going to build a large system with backend services. So I hope you will enjoy what I'm going to show you. So first of all, for those who haven't attended any of my sessions, first of all, the reason that I have this strange accent is because I'm not from the UK, I'm from Israel, and English is not our mother tongue, so this is my second language. If you want, I can speak in Hebrew the entire session. Yeah? Well, you can watch the video later maybe the subtitles, or just dub me. So my name is Ido Flatow. I come from Israel, from a company called Seller Group, a consulting company. I'm a consultant, a trainer, Microsoft MVP for ASP and IAS. I do a lot of training, a lot of course offering, also wrote a couple of books. Just finishing writing a book now with a colleague about single-page application development. He's writing the front-end side of single-page applications. I'm writing the back-end side with Web API. So I actually have no idea what 70% of the book is about. JavaScript. And along the route, I also created a course for Microsoft for developing web services. This is actually a condensed course, a 5-day course that teaches you how to use Entity Framework, WCF, Web API, and Windows Azure all in 5 days. So if you want your brains crammed with a lot of material in 5 days, just go ahead and attend the course. I assume you have centers here that train Microsoft courses. Anyone ever did a Microsoft course? I've been to a couple of conferences, and I'm always telling them I wrote the WCF course in a WCF session. And then I asked how many people actually attended an official WCF course from Microsoft, and I think that I spoke in front of about 500 people so far, and I think that no one actually, any one of them did a Microsoft official course. So here I asked, and only one person raised their hand, so that's the statistics about Microsoft courses probably in the world. Which is a shame because it took me 6 months to create that course. So, please, my company is earning money from selling it. Okay. So, first of all, this session, I thought of calling it an advanced session in Web API, but I'm fed up of referring to the topics in frameworks as advanced. They're not advanced, you just need to know how to use them. Okay, it's not how to write Web API in assembly, okay, or I don't know, how to customize the Web API framework so it will so it can be used with, I don't know, with the WCF subsets. Okay, it's not that. It's just knowing your way around Web API and skipping all the fundamentals that you were supposed to learn on the job training, during your work, such as what is HTTP and what's a request message and a response message and what are status codes and verbs. So for example, if I'm talking to about, there are about 50 people here, if I'll say an HTTP response 401, you'll probably know that that's an unauthorized answer, right? If I'm talking about, I don't know, controllers and action, you know that in order to invoke a controller, you actually need to configure a route for that controller. I know that, I think that in the UK you say route, right? Okay, so I'll say route, just convert it in your head. So I won't be talking about all of these features, but of course I will be using them, so they will show up, both routing, and the response messages and exceptions and validations. We'll see all of them during this session. I just won't explain exactly, for example, how a model state validation works. Okay, I assume you all know it's data annotations. Okay, so what we are going to talk about today is we'll start going over the Web API pipeline to really understand what happens to an HTTP request once it arrives to the Web API pipeline and until it reaches your action method and how you can actually customize that pipeline. We're going to talk about caching, HTTP caching, and how you can configure your web API services to send orders to the client-side caching. Okay. I won't mention server-side caching. Server-side caching is basically a feature of either ASP.NET or IIS. If you want, you can watch my session from yesterday, the session about IIS, where I mentioned how to do caching in IIS. We'll talk about streaming content to the client side, from the client side, downloading, uploading content. We'll see a couple of examples of how to do that with the web API. And we're going to talk about security. Okay, now, security by itself can be a topic for an entire day. So we'll try to focus on the concepts of authentication and authorization and see exactly how they work with web API, how we can tweak them, customize them, use different types of authentication mechanisms. Okay, so hopefully we'll get to that at some point. Are you obligated to leave this room at 11? Because I can continue until 1 o'clock. My flight is at 4:30, so I can. So let's begin with the pipeline. How many people here ever try to customize the web API pipeline? Anyone ever try to create an action filter or a message handler? Okay, so maybe some of you are familiar with those concepts, but first of all the people who are using web API know about 3 parts of web API. They know about the hosting environment. Anyone self-hosting web API services? Or are you all web hosting them in IIS? IIS? Yeah. Okay, so a host, by the way, which can also be a self-hosted with OWIN. You have the host, it receives the message, sends it to the web API pipeline. That's the first part of the web API pipeline. Second part is the controller, that API controller that you build, that class, that has a bunch of action methods. Now the question is how the message flows between the host until it reaches the action controller. So first of all, between the host and the controller, we have a bunch of classes called message handlers. Message handlers are basically classes that receive the HTTP request. They can view that request, verify it's okay, check the headers, check the body, change it even if you need to, and then just flow the message to the correct controller. Okay, we'll see exactly how that is constructed. Once the message is in the controller now needs to figure out which action to use, and then it needs to break down the request to the parameters the action methods actually need to use. So it can extract it from the body of the message, from the URI itself, from query strings. Okay, those are the model binding related classes. Then when the action returns either an object or an HTTP response message containing an object, that message goes through a conversion using all sorts of formatters, content negotiation, the entire concept of figuring out which serialization needs to be invoked, either XML, JSON, or your own customized formatting, and then flows back through the controller and back to your host, sending it back to your client. Okay. So to customize a web API pipeline, this basically means that you can customize each and every one of these parts. You can, of course, create new message handlers, you can create new formatters for the result conversion, you can create new filters that will apply between the controller and the action method. You can even change how a controller works, for example, how a controller figures out which action to invoke. Okay, you can even change how the host picks up the controller that needs to be used. Okay? Each and every one of those parts is either customizable or extensible. So I can also add my own logic and can also change the default logic of web API. So first of all, let's see if I want to bring my own implementation, how I can actually change the way the pipeline works. So first of all, for the controller part, I can actually change a bunch of stuff, such as the way the controller is being selected. Basically, how is the controller selected? It's conventional, right? It's the name of the controller, case insensitive, but it has to end with, it has to start with the suffix controller, right? If you don't want that suffix, you can just change the way you select your controllers. You can even change the way you search for controllers, because basically the controller is being searched throughout the assemblies of your project. If you have hundreds of assemblies and all of your controllers are concentrated in a single assembly, You might want to change the way that web API searches for that controller just to make it faster. Of course, once it finds a controller, it's cacheable, so there is no performance hit afterwards, but for that first request that answers that controller, you might want to change the way you actually look for that controller. Okay? So I can change the way the assembly resolver work. I can change how the controller is being activated if I want to inject some stuff to the controller, or maybe, I don't know, use a pool of controller objects instead of getting a new controller object every time I invoke a method. I can change the way the controller selects the action and the way it invokes it. If I want, for example, to, I don't know, do a different exception handling, I can change the way the action invoker works. These are all, as you can see, interfaces that I can simply create new classes that implement those interfaces and then replace the existing default implementation in the pipeline. We will see exactly how to do that in a second. So I can change or even add my own model bindings. So for example, if I have a parameter that needs to be extracted from two parts of the query string, I can simply create a new model binder or a new value provider if I want to transform it to a complex type that I'm creating, and just instruct the web API exactly where to take the data from and how to construct a new object out of it in order to send it to my method. So all of these, including the content negotiator, I can actually change and bring my own implementation. There is a default implementation for each of them. By the way, the simplest way to get those classes, the default implementation, is just using that name with the default prefix. So for example, the content negotiator has a class called default content negotiator. You can just search it up in the web API assemblies and look at its implementation, or just derive from that one and add your own implementation on top of it. So let's take a deeper look into the web API type, and let's start with the message handlers. Now, the message handler, as I explained, basically needs to take the request message, call your controller, get a response message, and send it through the host. Okay, but what actually happens in the message handler? So first of all, your HTTP request message is sent to a bunch of classes called delegating handlers. A delegating handler is basically an asynchronous method that receives a message, a request message, and returns asynchronously a response message. Okay? Between getting the request and sending the response, it actually needs to invoke the controller. So the first thing that you need to do is decide if you want to invoke the controller or not. Okay? So if I decide I need to invoke a controller, I'll just pass that message along to the routing mechanism, which will try to figure out which controller to use. Okay, at this point, I can actually even break the the sequence and, for example, examine the message, decide I can't handle that message, and send directly a response saying, I don't know, unauthorized, not found, or anything else that I can do in order to tell the client I don't have anything to do with that message. There's no point of sending it to my routing mechanism. Okay? So basically, once it's sent to the routing mechanism, it's sent to the controller, back through the routing mechanism to my delegating header. I can actually see the response, decide if I want to change something in the response, decide if I want to add headers to that. So for example, we'll see a demo where I'm actually checking the response and adding stuff to it if the response is a certain, uses a certain status code, and then just send it back to the host so it will return to the client. You can add as many delegating handlers as you want. You can even create delegating handlers that are per routing. So if you have, for example, a general message handler that you need to inspect all the messages, just push it in front of the routing mechanism. If you have a specific delegating handler that you want it to execute only for a specific route, you can actually add a delegating handler in your map HTTP route method. You're all familiar with the map HTTP route method, right? We'll see that. So this is how message handlers work. We can create new delegating handlers and just apply them either to the main pipeline or for a specific route. The second part is how we manage controllers. And by the way, we'll see a demo shortly showing exactly how to create all of this stuff, so don't worry. And the demos are already online, and at the end of the session I'll show you the link, and you can download all the examples, and then try that back at your house. So when we have a controller, we basically have a controller, an action, okay, and the question is what goes on between those two. So first of all, we know by now that we have an action invoker, that part that actually invokes our code. We also know we have a model binding that receives the request and parses that and creates object out of it and deserializes the content if required. And between the controller and the model binding, we have something called filter. Filters are part of code that are invoked either before invoking an action or after invoking an action. We have a basic filter which we can apply with shortly, but we also have specific filters. For example, an authorization filter is something that is invoked if you implement that. It's something that is invoked before even calling your model binding, just to verify that the user can actually invoke that action. Okay, so for example, I can check if the user belongs to a certain role or has a certain claim if I'm using claim-based security. We'll talk about that later on. And if they are not authorized to invoke that action, I can simply, at that point, return a 401 response or a 403, depending on what I'm seeing in the request, and just break the process at that point without even invoking the action. Now, if the authorization filter checked out to be okay, the user is authorized, then I'm going through the model binding, I'm parsing the content, not me, of course, web API, deserializing the content. Now I have a model state. Okay, so just before sending that model state and invoking the action, I have something that is called action filters. Action filter is basically a class, an interface that has two methods: before executing, after executing. So I can actually invoke code that does stuff before calling my action method. Okay, so for example, I can validate the model state. So any type of validation that you have, instead of doing it in each and every one of your action methods, I can actually do it in an action filter. Okay, just check that the model state is valid, and if not, return a response saying, well, a bad request, it's the client side fault. And after an action is executed, I can actually run a filter that checks the outcome of that action. So for example, check to see if I returned a null object, saying I have nothing to return. Or check to see if I returned the 404 not found and add some text to it. Okay? I can actually check the response itself and of course change that response if needed to. Another thing that I can catch is if something wrong happens during that exception, for example, that an action, such as an exception being thrown, not an HTTP fault exception, but a real exception, like, I don't know, a SQL exception or a non-reference exception, something I didn't expect, I didn't catch in my code, I can actually create an exception filter, which is a special filter that is invoked if an exception occurs, and it basically just provides me with the exception and the response, and I can decide which response I want to return to the client according to that exception. So I can grab the message from the exception and send it to the client. I can maybe just use the toString on the exception and get the entire set of message, including the inner exception and the call stack. Don't do that in production, of course, okay, because you don't want to expose that content to your client side. And besides that, your client side might be JavaScript, and what does JavaScript have to do with .NET exception? So you can also create exception filters, and we'll see exactly how to create that. So basically, the HTTP response message, it can be created from an authorization filter, from an action filter, from an exception filter, or just from your action method if you manage to get there and complete your code without any exception being thrown. Okay. So up till now we saw and understood how to create those extensions. Now the question is how to apply those extensions to our code. Okay, so as you might have seen before, we have that very cool configuration method of web API where we can do almost everything. Okay, we can add, for example, new formatters to the web API pipeline using that configuration method just called config.formatter.add and add your new custom formatter. Okay. If I want to replace, for example, the default content negotiator, I can just say config.services.replace, give it the type of the interface I want to replace, and provide a new implementation of that interface. So it will simply locate the default implementation that it has and just replace that implementation. I can even, instead of using replace, I can use get to get the default implementation. For example, if I want to wrap it, okay, call my code, which will call the default code. If I don't want to do it globally, I can also, of course, apply it either to an action method or apply it to a controller, depending on the type of the extension. So, if, for example, if I'm creating, I don't know, an action filter, I can simply derive from an action filter which provides me an attribute and apply that attribute to my method or to my controller if I want it to affect all of my methods. Now, if I want to, instead of doing it manually in each and every one of the controllers, I can actually even create a configuration class that will be applied to each and every controller. If I create a class that implements the iController configuration, I can actually create a class that has a method for configuration, so that that global configuration that I have for the entire pipeline, I can actually have different sets of configuration for each and every controller. If I want only one controller to support a specific formatter, I will add that formatter using that class. So I'll implement the interface, I'll get an initialize method. In that initial method, I will get a similar config object where I can add formatters, I can replace services, I can just tweak my extensions according to a controller instead of applying it globally. Okay? So it might be a bit vague right now, so let's go ahead and look at some code. Okay? Early in the morning, brace yourself, it's going to be hard. Okay, so first of all, just to understand the application that I'm using, has anyone been to my ASP versus Node session yesterday? Okay, so you might be familiar with this application. This is the agency application, an application we created to manage secret agents. As you know, we like secret agents in Israel. If you know someone, as I said before, at MA6, please give me his name. We'll try to do a sale here. Okay, so this application is basically an MVC front end and a Web API backend. Okay. Yeah, so we have a couple of agents. You're familiar with this guy, I guess, and there's also this guy. Okay, oh, it's not the right image, sorry. So we have here a back-end web services created with Web API. So let's take a look at these services. I'll also open Feeder here if we need to. Who here is not familiar with Feeder? Feeder? Okay. Are you a web developer? Yeah. First of all, as you might see, I don't have any API controllers in my web application. I moved all my controllers, all my extensions to a different assembly, just because I'm not sure if I want to host that web API service in IIS or using self-host. So I just extracted all the API controllers to a different project, which is here. And I can just go ahead and host it using a self-host if I want, using it with an IIS if I want. I don't need to change any of my code here. I actually added a bunch of code in my controller to actually check if I'm hosted in a web or in self-hosting, just so I know, for example, how to map the local folder that I need to use. So first of all, let's take a look at some message handlers and some of the action filters I'm using here. So first of all, as you saw, I didn't have any problem invoking the MVC application, calling the MVC application, and it called successfully my web API services, because basically, currently I don't have any security in my application. So the first thing I can do, for example, is to create a security level for my application. Now, we haven't talked about security yet, so I'm going to do the most simplest security check that can be. I'm just asking for username and the password in the authorization header of my HTTP request, and I need the username be identical to the password. Okay. So I created a message handler for that. It's called the authorization message handler. And as you can see, it derives from a delegating header. That's the class that we are using. And it has a send async method, which takes in a request message and returns a response message. I can inspect the request, check if I got the authorization header in it. If not, just pass it along to my controller to check if the controllers actually need authentication or not. If the controller returns a response that says I need the user to be authenticated, then I'll just add a header saying which authentication type I want the user to use. So I'm using the basic authentication type, which is basically plain text, username, and password. Now, once I do that, the only thing I need to do is just attach this message handler to my pipeline. Okay? So first of all, let's just go over the code. I'm checking the authorization header. Okay? It's strange, but the authentication process is handled by a header called authorization. I have no idea why. HTTP back in 99, who knows? And if that authorization header has a value, then I'll just put it, decode it, as you know, a basic authentication is the base 64 string, but it's basically just plain text. It's not encrypted, it's not signed, not anything like that. So I'm just converting it from base 64, splitting it to get the username and the password, okay, and just validating the user. Validating the user is break. What did I press? Validating the user, as I mentioned, is simply checking that the username is equal to the password. And if it's okay, I'll create the identity, even create a list of roles for that user, just as a sample, of course. Okay? Don't do this in production. Always use some sort of an identity provider, Active Directory, I don't know, Twitter accounts, Google accounts, whichever. Just don't do it on your own. So if it's okay, I'm sending. If it's okay, I'm sending the request now to the controller. The controller can actually verify that the user has been authenticated. If the user is not authenticated, I'm creating a response in place saying it has to use the basic authentication. And I'm just here sending the response. I'm stopping the pipeline. Okay, the action will never reach my controller if the user is not authenticated. So let me just add the authorize header to my get method. Okay, so this means that when a client wants to get the list of agents, they actually need to get authenticated, and they also need to belong to the admin's role. So if I'm authenticated, I should belong to the admin's role. This is the thing that I'm doing here, admins. So all I need to do now is just attach that message header to the pipeline. So let's go over to our configuration, and scroll down, and here let me just go to my config, message handlers, add new authentication message handler. Just add that to the global message handler collection, save file. Now, since I'm using basic authentication, the browser will identify that situation and will simply pop up a message saying, please enter username and password. That's how that works. Because I have a bunch of other authentication stuff here. Actually, I didn't have time to test that, but it should work. Just see what's going on. Okay. It's working. Still no response. See. Agents 500. Wait a minute, did something wrong. What happened? Cannot authenticate the user because what? The URL scheme is not HTTPS and without SSL. I have a bit of a problem here. Let me just try to change my code. I prepared this code also for the security part afterwards, and there might be a couple of issues here that I need to remove. Just do this. Hopefully this will work things out. Right now. There's a mix and match of security techniques in this project which might affect it. And just hope it works. If not, I'll open a different project where I have this code and I'll show you how it works afterwards. Come on. Make that proud. Come on. It's being recorded, right? Oh, yes. Okay. So just enter my username and password, and I get the list of agents. If I didn't enter the code correct, the username and password accordingly, I would have received that message box 2 or 3 times, and then once 3 times have passed, I will just get an error in the JavaScript, and then I'll be able to show a message box saying you need to authenticate in order to see the list of agents. But basically, what happens underneath the hood is just I'm getting a 401 saying you have to authenticate yourself using the basic authentication mechanism, and then I'm just sending it again. And here you go, we have here the authorization header. Okay, and it looks encrypted, but basically just the basics. Before I can copy this value, go to my, where is it? Text wizard, and I'll show you in a second what it looks like. This is your username and password. Okay, that's where you have to use HTTPS if you're using a basic authentication. Okay. So a message enter is one of the things that we can do when we want to extend our pipeline. Let me just turn that and check this comment. We can also add, for example, filters. For example, if I want to validate my code before invoking my action method, I can create an action filter. This is basically a class that derives from the action filter attribute. So it will also provide me this class as an attribute I can attach to either an action or a controller. I can implement either the executing or executed method. So if I want to validate the input, I will probably use the executing, which happens before my action is invoked. I'm getting the model state in this action filter because I already passed through the process of extracting the data from the request. So I can simply check if that model state is valid. This basically runs the data annotation validator on my objects. I have here in my data model a list of restrictions, such as the ID is required. It needs to have a string length of maximum 10 characters. The full name is also required and has to be up to 100 characters. It just checks those validation rules, and if something is wrong, I'll just create an error response, okay, saying this is a bad request, and I'll just send the model state to this create error response method, and it will create a JSON object just saying which property was faulty and the message that is appropriate to that validation. Okay, so I can do that using an action filter before. I can even do it afterwards just to verify that I managed to create a response. I can create, for example, exception filters and handle any unexpected exception in my code. So an exception filter attribute basically provides me with a method called onException and the context. That context contains both the response and the exception object. So I can just pull the exception object from the context, check its type maybe just to verify. For example, I can create a different exception filter to handle SQL exceptions and another exception filter to handle my own custom application exceptions. Okay, just pull the exception, check its type, and then create a new response exception and just throw a response exception containing the correct text that you want to send to your clients. Okay. Now to apply these are basically attributes. So, for example, if I want the exception filter, I can just go to a controller and just go here and say, for example, give me the exception filter. Okay, so unhandled exception filter. If I want to edit globally, I'll just remove it from a controller, go back to my web API config, and just apply it globally to the filters collection. Okay? It will apply it to each and every one of the controllers that I have in my service. So this is actually the correct way to do that instead of just applying it to each and every one of the configurations. Now, if I want to change the filters and the formatters and the message handlers for just a specific controller, I can simply create a custom a custom controller configuration. I'll derive from the attribute class and implement the iController configuration. I'm getting the initialize method where I get that controller setting configuration. It's basically the same object as that config object. So it has, for example, what else settings? So it has formatters, okay. It has the services, it has parameter bindings, so I can simply replace the parameter bindings. I can add new formatters, I can replace existing services, so I can replace stuff like the content negotiator. Okay, the content negotiator is basically an interface that tells you this is the MIME type that the user wants, this is the object that you want to return, this is your response message, now these are the formatters that we have available, do your magic, tell me which formatter to use. Okay, so you need just to go over the formatters and decide which one you can use to create a response. And again, applying that to your controller, it's just apply that as an attribute or just add that manually in the global configuration. Okay. You'll have this code, so you'll also be able to see exactly how the code in each of the filters and message handler works. There's also a bunch of formatters there to create CSV files and image files, so you can check that out later too. Okay. Any questions about pipeline? And again, I'll also be available after the session for about an hour if you have any more questions. So don't feel the need to ask your question now if you want to grab a couple of questions.
One quick question regarding get methods, basically, get actions, basically. So if I have to pass multiple parameters, by default, every documentation or every Stack Overflow article says use, if it's a custom object, use post methods rather than using just get.
Yeah, the problem with a complex object is basically constructed of properties. The usual place where we pass complex objects is in a post method because we send it as the body of the message. And because in the get, the default way that Web API binder will work, it will extract information only from the query string. We don't send the body in a get message. Now the problem is that for complex objects, an object won't contain only a string and an integer. It might also contain another complex object. And you can describe that easily in a query string for a get request. If you do have the need to send a complex object in your get request, then you might want to create your own model binder to extract that query string. I don't know, use curly brackets and create some sort of a JSON object there, for example. And you create a model binder that will extract information from there and then deserialize it to the content that you need. And then pass it as a complex object to your get method. But usually, yeah, a get method should receive some basic parameters that just so it will know how to filter the content, that sort of stuff, not a really complex object that has a lot of content in it. Okay? But you can do that if you have a custom model binder. Okay? So, caching. First of all,
another question. The architecture looks to me very similar to MVC.
Right.
Can you use any parts, some filters, action filters?
It's a trick question because actually for some of these, for the exception filter and for the validation stuff, there are actually classes and interfaces by the same name in MVC, but they have different namespaces. Okay. So currently, you can't actually use the same classes for both Web API and MVC, but you can, of course, take all the logic out of those classes, put them in a common class, a shared class, and just call that class from both implementations. So create a custom exception filter in MVC, a custom exception filter in Web API, and have both classes call the shared infrastructure to create the response. Okay, that would be possible, but basically it's a different assembly because you can, for example, host Web API in a self-hosting environment where you can't actually, or at least not now, you can self-host an MVC application. Okay, so it comes from different namespaces, but by the way, you don't actually need to create an MVC application in order to use Web API. I hope you know that. Some people tend to think that the full name of the Web API framework is ASP.NET MVC Web API. It's not. It's just ASP.NET Web API. It has nothing to do with MVC, other than the misfortunate decision of Microsoft to always create an MVC code in a Web API template. Okay, just so you will see user interface, Microsoft type user interface. But different assemblies, different implementation. Okay. So caching. Now I imagine all of you are using client-side caching, whether you want it or not, because servers, web servers, always send caching headers for static files. The problem is that we almost never send caching headers for dynamic content. Now we are creating Web API responses, so those are dynamic responses. They can change over time, of course, but still sometimes if we create a controller, I don't know, a general controller to return a list of countries, how often does the list of countries change? Okay. How often does a list of I don't know, cities in the UK change, a list of streets in cities? You have a lot of what is known as lookup data in your application. Just lookup tables that you pull and provide to your client side to build list boxes and sets of checkboxes, and that content rarely changes. So why not just add caching headers to those responses to inform the browser to cache that content? Okay, caching that content will reduce the number of requests sent to your Web API service. It will increase, it will reduce the time it takes for a browser to load the application because it already has the content in the cache. And basically, it can just improve the way your application works and its overall performance. Okay, less calls to the server, the better the server handles loads when actually there is a load. So, first of all, the most important header you need to know about is the cache control header. Now, it appears that actually Web API uses the cache header, the cache control header, and just sets it to no cache automatically. Just look at your messages. For example, let's look at feeder. It still has stuff here. Let's see. Headers. You'll see that it says no cache. Now, what is no cache? Basically, no cache means I don't need the content to be cached. It doesn't necessarily mean that the browser must not cache that content. Some browsers, such as IE, will cache that content, but will check the expire date to an hour before. So the next time user requests that content, the browser will actually ask for it again. The only reason why they cache the content is, for example, if you have a network failure, and in that case, it's able to load the content from cache instead of asking the server again. But if there is a network connectivity, most browsers will just send the request again to the server. And that's the basic idea of Web API. We don't want to cache everything. Okay? If you do want to tell the browser to not even store any bits of the response, you can just set the cache header to no store, to instruct the client not to save the content. So if it's sensitive information, I don't know, an application showing a list of credit cards, okay, set it to no store. If you want to control how much time an object is stored in the cache, you can set in the cache control setting called max age. And max age basically tells the client, please store that information for the next couple of seconds. You can actually specify the exact number of seconds. If you want the cache to be stored only on a client machine and not on intermediaries, proxy servers and stuff like that, CDN servers, you can actually set in the cache control header private, just write it private, and it will inform every proxy that the message flows through not to store it locally. It doesn't mean that the proxy won't store it, Okay, if the proxy respects HTTP protocol standard, it will skip saving that content. It will only be saved on a client-side browser. Okay. Now, all of these things you can control from Web API without problem. The second thing that you can control is a header code expires. So you can control when a content expires using the message, but that requires you to calculate the exact time that you want the message to be sustained in the cache. Now, for example, if I want the message, the response to expire on January 1st, okay? I don't know, it's some kind of a fiscal content that has to be rechecked every change of fiscal year. Where's the fiscal year in the UK? It's January or March, like the rest of the world? April? Okay. So you can expire it on April 1st or January, March 31st. And instead of calculating how many seconds you have until that date, you can just set the expire header to a specific date and time. Okay, but just be aware that you have to set it using GMT, not because it's the UK, because that way it calculates the exact time it needs to revalidate it on the client side, because the client may be in the UK, maybe in the US, in Asia, wherever. Now, if you do set both headers, message and expires, message takes precedence. Okay, so don't set both of them, set only one of them. Now, the basic concept of cache is the following. If the browser takes a response and stores it in the cache, and then you open up a web application that needs to call the service for that same request, the browser will check if the cached content is still valid, according to the expires. If it's valid, it won't even send a request to the server. If I open Fiddler, for example, I won't see a request being sent to the server. It will just use the cached content. So you will even feel it in your web API service that you're actually getting less requests because your client is caching content. Okay? So that's a very cool feature because it reduces the number of requests your web API has to handle. To control those caching headers,
Yeah, just a quick question. How do you force an expiration then? Say lookup does change and you want to force that.
So usually what you do is when you build your JavaScript, that, for example, a jQuery function that needs to retrieve that information, you might want to change the jQuery to add a question with timestamp. The timestamp will be different between each and every request, and that way it will, or a version instead of a timestamp, that way it will force a new message to be sent to the server. Actually, I have a demonstration of that here. Basically, controlling cache in client-side is not a new thing. It exists in ASP.NET since, I think, version 2, maybe even 1.1. But the problem is, it's only for MVC and web forms, it's not for web API. Okay? I suspect it has something to do with the fact that web API can be self-hosted outside of ASP.NET. So you can actually use the output cache attributes of ASP.NET in web API. They just they won't matter to the pipeline. In order to control the cache, you have to manually set the headers. So you create a new object from the type cache control header value. You set it to either max age or private or no store, whichever you need, and then just go to the response object, that headers, that cache control, and place that object in the cache control. Okay, for the expires, you need to go to the response, to the content, and then there's an expires property there that takes a date and time. Okay? It's a date time offset. So, cache headers, cache control and expires is one set that defines for how long a browser will cache your content. The third header actually that we can use is a versioning header for your content. So there is a special header inside Web API called eTag. eTag, entity tag, represents the version of the resource. Now the concept is as follows. First of all, I'm sending a request to the server. It's probably a GET request to get that content. I'm not familiar with that server, I'm not familiar with that resource, so there is no eTag involved here. The server will receive the message, it will retrieve the data from the database, pull the version information, and place that version inside the eTag header in the response message. The client retrieves that message, stores it in the cache, of course, if you specify the cache headers, and also stores the ETAG version. Okay. Now, the second time I need to send a request to the server for that same resource, the browser will pull the ETAG information that is stored in the cache, will place it in the request, and send it to the server. Now, when we get the request in the server, we actually have the ETAG version in the request. We can pull that ETAG version, pull the data from the database, and check if those versions match or not. If they don't match, meaning someone already updated that resource on the server, we'll just return the new object and, of course, return the new ETAG so the client will know it's the most recent version. If it's the same one, we actually don't need to return any content to the client because the browser already has that content in the cache. So we only need to return an empty HTTP response with code. Which code? It says in the slide. With code 304. 304 unmodified instructs the browser to use the content that it has in the cache. So if you've ever seen in Fiddler or other network sniffers 304 responses from a server, that means that that server got an ETAG and verified that that ETAG hasn't changed. It also happens, by the way, for static files. IIS automatically creates an ETAG based on the file modification date and stores it as the ETAG of that file. So every time that you send a request for an image again and again, it will simply return a 304 if that image hasn't changed. Okay, it's automatically handled by your web server, but for web API, you can actually do it on your own. Okay. Now, just to heads up, when the ETAG header is added to the response, it's called ETAG. When the ETAG header is added to the request by the web browser, it's not called ETAG, it's called if none match. Now, that name might it implies that the ETAG can actually be more than one value. Okay, so if you have a complex content, you can actually store a couple of versions in that ETAG. Just add a comma between each and every one of the versions, and if none match, it will provide all the versions, you will be able to verify them on the client. So if you even return a list of objects, you can just add the ETAG, the entire list of versions, and then check if you need to return a new list or not. Okay. So another thing that you can use ETAGs for is concurrency. Imagine the following scenario. You get a response from the server containing an entity. Someone else updates that entity in the meanwhile, and then your user edits that entity and tries to send it to the server. Usually it's last one wins, right? But sometimes we do want to check concurrency and verify that the user doesn't update content that was already updated by a different user. So since we got information firsthand, we have the ETAG of that resource. When a browser sends a post or a pull request, it also adds that if none match header. So we can basically just grab that header in our post action method, or in my put action method, and check that if none match, if it corresponds to the version in the database. If it's not, I'll just send a bad request to the client, or to be more specific, a precondition fail, which will inform the client that I can't update the entity, you have a previous version of the entity, please refresh your content, because once they send the new GET request with the incorrect ETAG, they will get the new update and the new ETAG, and then the post message will work. Okay. So let's take a look on how to do that. So what I have here in my API controller, I have a caching filter that I created. Okay, and that caching filter is an action filter. And in the executed method, after I have the response, I'll just append the cache control header value, set it to the max age that the client sent to me, not the client, the code sent to me, which is 5 seconds. Is it seconds or minutes? What did I do here? From seconds here. Set the max age and attach that cache control object to the headers. And if I just need to show this line, I won't add the caching header to each and every one of the response because it doesn't make sense to return a cache header for a 401 response, for example. So only adding that caching header to 200 messages and to 304. Now, why do I add it to unmodified? If the client had a cached resource and it expired, and then it sent to me a request to get an updated content, but there is no updated content, so I'll just inform them, please extend the period of that cache content to another 5 seconds, or another 10 minutes, or even another year. Okay, the message can be up to 1 year. So that way I don't need to actually send new content again and again to the client if that content hasn't even changed. Okay, you can just prolong the cache period. So I'm applying this using a cache filter, compiling, and now let me just go ahead and this is for the get by ID. So let's here. Okay, let me just show you what happens here. Okay, so I'm requesting to get information about bound. This is the one that is supposed to be returned with the cache header. Let's give it a second. Okay, and it actually returns me in ETAG because it's already cached, so let's clear the cache. Refresh this. I already have the ETAG stuff in the code, so just return 304. It should work now. Here. Security stuff. Just, forgot to remove one thing. Disable the security stuff, so just remove all. After a build, it takes a while to execute the first request. Come on. So we have, for example, this one here. And if we look at the content, this one was to get the content of an agent, it returned a JSON object, and has the cache control header set to max age 5 seconds. Now, if I press another agent, it will request the content of that agent. If I go back here and do a bit of clicks, you will be able to see now that it only sent request to get the list of nemesis, to get the list of observations. It didn't request to get the information about the agent again. I'll wait for 5 seconds. Now let's try that. Okay, and now you see that it sent information, it sent the request again, but as you can see, the server returned a not modified. Now, how that happened, in my code, in the get by ID, I have here return agent with ETAG. If we look at that code, what we do is, first of all, we retrieve the agent from the database because we need to know the version. And we simply do the following. Get ETAG simply retrieves the if non match header. Okay? And then we compare that value to the agent's version. If they match, we just return a new HTTP response message saying not modified. If they don't match, we'll create a new response with that agent and we'll set the ETAG value to an entity tag header value with the value of the new version. Now, the only thing you need to remember, ETAGs, according to the HTTP standards, are supposed to be surrounded with double quotes. Okay, so just quote them, and you'll see that the result is like so, okay, with quote signs. Let me just this one. First one was return ETAG, double quotes, and the version. Okay. So that's how we use ETAGs and cache. It's not that difficult. Okay. Questions about caching? Yeah, I do. I hope I can hear you.
Yeah, is it also supported using the HTTP client?
Sorry. The HTTP client is the .NET object for HTTP communication. Basically, .NET clients don't do anything with cache content. They don't cache it anywhere. You can, of course, if you are implementing an application, you can check the response, see if there's a cache header in that response, and then take the content and store it in memory or in how is it called in desktop applications? Isolated storage, I think. You can store it manually and just check again before you send a response, send another request, sorry, if that cache content expired or not. Okay, just set the, a cache, a daytime value for that object, and it's probably going to expire. Okay, so you have to do it manually. As of now, as far as I know, automatic caching is only supported by browsers. Okay, now I didn't see that happening on Windows Phone either, and in other .NET applications. The third topic we're going to talk about is streaming. Now, I hope that I don't need to explain to you why streaming is important, but let me explain to you anyway because it's in the slide. Streaming, basically what it does, it prevents both your client and your server from buffering the entire response in memory. Okay, I don't know if you're familiar with the concept of .NET, but .NET has that stuff called garbage collector and heaps and generations, and there is something that is called a large object heap. Anyone heard of that? The large object heap of .NET? If you have a byte array that is more than 85K, 587, that entire block of bytes is stored in a special heap called the large object heap. The problem with the large object heap is that it's cleaned infrequently, rarely, and it has fragmentation issues. Okay, so if you see your W3, WP process increasing over time, that might be because you allocate large byte arrays, and when you deallocate them, some of the memory is actually still available and can't be used because it's too small for any other object. Okay, so to use streams smartly, you have to work with stream content. When you upload files to a server, when you download large content from a server, you should use streaming in .NET, meaning you have to use the stream classes or other sorts of stream techniques. So if you want to upload and download files, use streams. If you want to provide live data feeds, for example, if you want to push some stuff to your client, if the client requests a response that you need to collect a lot of data in order to complete that response, so instead of having the client wait for 2 or 3 minutes, you can just send them bytes of the response, one object and another object and the third object over time, while you are still collecting the information from different services that you need to call. Okay? So when we use streams in .NET, we're actually using a technique of HTTP called chunk transfer. Anyone ever heard of that? Chunk transfer? Yeah? So first of all, there are a couple of things to note about chunk transfer. First of all, you'll see that you're using chunk transfer by just looking at the HTTP response. It says transfer encoding chunk. Okay. The second thing you'll notice is that there is no content length header saying that I don't actually know the size of the response. That will allow the client to just read the content again and again and again until it reaches the end of the response. The concept of chunk transfer is that we are always sending chunks over the pipeline. We send the size of the chunk and the content. The size itself can vary, so it can be 100 bytes and then 200 bytes and then 3K. And once we're done, we just send a chunk of size 0 that instructs the client to start processing the request, the response, and assume it's done. Okay. So don't send 0 anywhere else other than the end. If you want to send, I don't know, a keep alive of some sort, just send 1 byte. Okay. Now, how do we handle stream content in Web API? So first of all, let's talk about uploading stuff to Web API. If you're uploading stuff from, say, JavaScript, uploading stuff from JavaScript usually means submitting a form, right, with, I don't know, a file attachment or something like that. When you submit a form that has a file in it, you're actually sending, the browser will send a request with a specific MIME type called multipart form data. Okay? It can be multipart, it can be, it's an XXX multipart form data or something like that, which basically contains a bunch of key and values and a byte array. Okay? So to read that content, there is a special method that you need to use that is called read as multipart async. We'll see that in a second. If you're sending streams from a desktop application, for example from .NET or from other applications, you're probably sending a simple byte array over the network, okay, without the special MIME type. In that case, if you're sending an octet stream MIME type, you can use the method read as stream async. We'll see that in a second too. If you are sending content from Web API to your clients, if you need to send them a file, okay, you got a file from the disk or you got some binary content from the network, you want to just stream it down to the client, you can set your response content to a stream content. There's string content, there's object content, there is a stream content. That will simply copy the content asynchronously from the input stream to the output stream, which is the response stream. If you want to send something that is takes a lot of time to construct because you need to call other services, you need to construct a response, you might have a list of objects that you need to create, you can actually create a new class called push stream content, new object for that class, provided with a delegate, and that delegate will simply do the work of pulling the data wherever it comes from and sending chunks of data to the client over and over. Okay? Just remember, each time that you're done with a chunk and you want to write it to the pipeline, call the flash command, the flash method, on that push stream content, just to make Web API send that content to the client, because otherwise it will buffer it in memory until it reaches a certain size, and only then it will send it to the client. Default size, if I'm not mistaken, is 2K or something like that, but of course you can change that. So let's take a look at some of these examples. First of all, let's see the scenario. For example, I want to change the image of an agent. Okay? Yeah, I cleared the cache, so I got this image. I want to change the image, so let me just browse and select a different image. I have one here. Agents, the real one. Place. Okay, it's a big image. And this is now the new image that is replacing the previous image. So first of all, that previous image was cached. So here's the technique that I used to change the cached image. I'm simply using, let's see if I can see that here. I'm simply using a timestamp which causes the cache to ignore the cached content and send a new request, because this is a different URL. Okay? And how did I actually change that image in my code? If we go to the agent controller, there's an upload image from for method. I'm getting the content, of course, in the body itself. This is a post method. Okay. I'm just doing some code to verify if I'm hosted, self-hosted or web-hosted, just so I know which folder to save it to. And then what I'm doing is the following. Creating a multi-form data stream provider. Multi-form data stream provider is a class built into Web API that knows how to read the attachments from that request message, and it automatically saves all the files locally to the hard drive to a temp folder. Okay? So when I call read as multipart async, using that stream provider, it will automatically pull all the attachments. I only uploaded one image, but there could have been several images over there. And it automatically stores them to a temporary file, to a temporary location with a temporary file name. Now that's not good for me. I want to move those files to my application. So all I need to do is to go to that stream provider, to a collection called file data, and I can actually access each and every one of those files and get the location where they were stored on the hard drive. So I'll get the file data information, I will check exactly where these files were stored, and I will just use the file move command to move them to my location where I want to show them. Okay, because I'm pulling the image directly from the web server, so I can't use it in temp file, I need to use it under my working folder. Okay. I can also get from, sorry, I can also get the name of the attachment as it was in the client side, because I'm getting a temp file, so I need to change it to the name of the original file, perhaps. So I can also access that information from the content. Okay, I can get the original name of the file on the client side. That's the, sorry, that's actually here in the file data. Yeah. And just move the file to a different location. Now, that is if I use submit from HTML. Now, as someone asked before, sometimes I'm using HTTP client to communicate with my service. I don't want to create a form request from a .NET application. I want to just use a stream content and send a stream to the server. So if I have a .NET application, which I have here, I have a .NET application here that uploads an agent's photo, and that .NET application uses HTTP client. It creates a new file stream to read the JPEG that I have locally. It creates a stream content and just posts that stream to the server. I don't need to read from the stream, create a while loop and that sort of stuff. It's just basic copying. Okay, streams have the ability to copy from one to another, so I'm just providing it the content. It will read from the stream and write to the request stream. So to handle that on the service side, this is even easier than using the form submit. Okay. Again, the code that has to do with locating the current working folder, if I'm self-hosted or not, and then, sorry. Okay, and this is all the code that you need to grab the stream from the request. Sorry, this one is here. I'm missing the line here. Request content read as stream. This is the stream from the request, and I'm just saying to that stream copy to async the file stream, and we just copy the stream from the request to the file, and of course close the stream afterwards, just so it will flush the last few bytes, and that's it. Pull the stream from the request and send it to a file. You can send it to a network location. You can send it to a service as a stream. You can do whatever you want. It's a .NET stream, after all. Okay. Now, to send content to your client, as I said, we can do a push content. For example, let me show you the following. Let's say that I need to load a large list of agents from an external service, and I want to just send the agents one by one to the client. So what I'll do the following. First of all, I'll enable my client side to use stream content in JavaScript. jQuery Ajax calls can't use chunk responses, so I have to directly use the XML HTTP request object in JavaScript. I have this code here. Okay, so I'm creating an XML HTTP request. I'm sending the request to the server. And every time I get a ready state change, that event will fire every time there's a new content in the pipeline. I'll just grab that content. I'll read the number of bytes that are in the content and deserialize them into JSON, and then just add that JSON object to my view model, and it will automatically pop up in my UI. Just to call that part, I need to uncomment one line, and put these comments. And what I have now is the following. Let me just go for a second. Come on. Next time I'll write it in JSON, it will be faster. wait sleep for 2 seconds between each and every one of them just to mimic a heavy load. Now, if you look at how I did that part, I was just sending a JSON object to the client, waiting for a couple of seconds, and sending another JSON object to the client, and I send them over a single pipeline, single response stream. What I did here is I created the following. First of all, let's get back to our agent controller. Where is it? Get as a string. Okay, and what I did here is the following. Created a response. The response type is octet string because it's a collection of JSON objects. It's not an array. I'm just sending one JSON object after the other. If we look at the response, it actually looks like anyone seeing that? No, here it is. Sorry, this one. Okay, let me just truncate that. It's size, JSON, size, JSON, size, JSON. Okay, so how did I create that? The content is push string content, and I'm providing to it a delegate that does the following. Creates a string writer just so I can create a JSON object. And for each of the entities that I'm pulling from somewhere, I'm creating a string builder, text writer, JSON serializer, pull the agent object from somewhere, serializing it into the text writer, and getting a JSON string. Taking that JSON string, writing it to the string writer. That string writer wraps that string from the push string content, writing it, flushing the content. Getting the object, writing, flushing. Getting the object, writing, flushing. And of course, just meaning the long wait, sleeping for 2 seconds. Okay. If you want to check the content of this response, if you have Fiddler, you can just right-click the request, the session. While it's still downloading, right-click it, and there's an option called comment peek here. It will actually show what's in the pipeline so far, without needing to wait for the entire response to reach the client. Okay, so if I'm doing it like so, I'm able to see it, the first one, second one, and then I'll just click, comment click again, and then I'll see the entire list and use the 0. Okay. It will have been a long list that takes a couple of minutes. I could use it to just watch it as it goes on. For the fourth option of just streaming a file down to the client, I'll let you do that code. It's quite a simple code. Just create a new stream content object, attach it to a file, and attach that to the response. Now, the last thing I want to talk about is security. Now, as you can see, this content is for an entire day. We won't talk about all of that. When we talk about security, of course, there's HTTPS. When we talk about authentication, we can do authentication in several levels. When we talk about authorization, we can use either roles or claims. When we talk about security, we also need to talk about input validation and error handling. So first of all, input validation, error handling, that's basics, right? That's the fundamentals you should be familiar with. And we actually saw how to create an exception filter earlier today. Now, what we need to talk about is all the other stuff. So first of all, let's talk about authentication. Now, the authentication basically is the process of identifying your user. Not checking what it can do, but just figuring out who this person or machine is. We can do it in several ways. First of all, we can do it outside the web API pipeline. If you're creating an MVC application, like I did here, and your web API is part of your MVC application, then you might use stuff like form authentication, or the OWIN extensions that allow you to add Google or Facebook credentials. That way you log into your application, you open your application, you are redirected to a login page, you enter the information there, and then you're redirected back to your MVC application, and now your MVC application has a principal for your identity. Okay? Now, once the MVC application has that principal, Web API will also have that principal because it is created by the ASP.NET framework. Okay? So you don't actually need to do anything in Web API in order to get that principal and start checking the authorization stuff for that user. You can even use the IIS authentication modules, for example, if you want to use Windows authentication. Just let IIS do the negotiation with the client to get the correct credentials, and once it receives that, it will notify ASP.NET. ASP.NET will create the credentials, the principal, and both MVC and Web API will know who that user is. So if I'm doing it outside of the pipeline, there are various techniques of how to authenticate our users, but they don't have anything to do with Web API. If we do want to authenticate the user using Web API, then we'll probably need our user to send credentials to our client. Okay, by the way, I didn't mention, but this is also known sometimes as passive authentication. We're being redirected throughout various pages, and we're passive. We're just entering the user and password. The pipeline does, the ASP.NET pipeline does all the rest. In MVC, in Web API, if there's a client that actually only wants to call the Web API without going through the MVC application, for example, the .NET client, we want that client to send the credentials directly to Web API. So we probably need to create some sort of a controller that receives the user's information and returns a token for that user. We'll probably want a message handler that validates the token on each and every one of the requests. Okay? And once it validates the token, it will probably create a principal for that user in the message handler. And only after that is complete, the message handler will send the request to the controller, and the controller will know who is the user according to its principal. Now, of course, you don't need to build it on your own. There are plenty of libraries that were created for Web API. For example, one of the famous ones is from ThinkTexture. It's called ThinkTexture.identityModel.web-API. It's a NuGet package. You can download it as long as the NuGet website is up and running, as it was down yesterday during my session where I needed to show NuGet. So that NuGet package has a lot of options to authenticate users using OAuth and OpenID and other techniques. But as you saw, we did something similar. We created a message handler that authenticates users according to a basic username password. Okay? If I wanted to make that code a bit more complex, I could have added some OAuth implementation, for example. Once our user is authenticated, we need to handle the process of checking who the user is to verify that they can actually use the action method that they want. Because the fact that the user is authenticated doesn't mean that the user belongs to the role that has permissions to do that stuff. So the first thing we can do is to use the authorized attribute. So the authorized attribute basically just verifies the user is authenticated. So not using the authorized attribute simply says any anonymous user can use our Web API. So usually we'll put that either globally in our configuration or on top of our more sensitive controllers. Okay, it will just verify the user is authenticated. If we want to test that the user is also a part of a specific role or has a specific claim, we can just, for example, if it's a role, we can add the roles parameter to the authorized, just like I did in my Web API, and specify the name of the role the user has to have. Okay, if we are authenticating against Active Directory, ASP.NET will retrieve the roles of that user from Active Directory. It's the user groups, of course, and we'll just set the roles to be the names of the groups. If we are using claims, we might want to use the claim authorized attribute from ThinkTexture, the same package we saw before. That will map claims, all the claims from the token to the principal, allowing us to check if the user has a certain claim. By the way, if you're using stuff like ADFS or Active Directory with claims, the group claims are turned into roles, so you don't have to actually do it manually. Okay. If you are placing, for example, the authorized attribute on top of your controller, and you want a single method and single action method to be open to anonymous users, just add the allow anonymous attribute on top of it, and we'll disable the authentication check for that specific action filter. If you want to create your own, just derive from the authorization filter attribute, just like we derived from the exception filter attribute, and add your own code to check if the user is authenticated or not, and throw an exception if it's not. Okay. So let's do a short demo of that, and that will end our session for today. So I have two techniques of authentication here. The first one is passive authentication through the MVC application. For that, I'm using the Windows Identity Foundation, also known as WIF. Familiar with WIF, anyone? I share your pain. So WIF is, by the way, all the security settings are usually done when you set up the project. If you recall the new web application project, you can actually select the authentication method. If you're using Windows Server 2000, Visual Studio 2014, let me just show that for a second. When you create a new project, web, you have the options here. Change that. You have the options here, for example, if you select MVC or even Web API, you can change the authentication to individual users' account. This will actually create a database with users, and you can also connect it to Facebook or Twitter stuff. Organizational accounts will connect you to Windows Azure Active Directory or Office 365. And Windows Authentication will connect you to your Active Directory or local Active Directory using IIS Windows Authentication. Okay. If you want to do something other than that, customizing it, and this is what we'll do here. So first of all, for the MVC part, we are using, for the entire demos, first of all, I'm using Windows Azure Active Directory, because that's the place where I can manage users. I'm not connected to a domain here, I don't have Active Directory. So I'm using an online Active Directory. And that is why I had these modules here to manage the WS Federation. This is part of the Windows Identity Foundation called WIF. There's configuration here. Okay, the system identity model that shows exactly how I want to connect to the system. And basically what happens here is once I go to my MVC, okay, this is the MVC part. Remember MVC? Yeah. And I'll add the authorized header, and to your question, this is MVC authorized header. There's also Web API authorized header. I will run the application. The MVC controller will see that the user is not authenticated. It will redirect the user to log in to Active Directory. And then after I enter my credentials, I'll hit my application, and the Web API code will also work. So, or not. Oh yeah, I need to use HTTPS for that, just a second. Yeah. All of this stuff was already tested on board. Smaller solution. Okay, let me just note I'll run it in debug, and I'll just show it to you here. Controller, get, and even do this. 5, drink some water. Wait for 5 seconds until it compiles, goes, runs, redirects, yes. Okay, so right now, if you'll notice my address bar, you'll see I'm getting redirected to the Azure Active Directory. In a couple of seconds, just need the application to load. Come on. This is, by the way, an i7 machine with 8 gigabytes of memory, SSD drive, but still ASP.NET. Let's use another account. My account is Ido and this is my domain, so I have a picture of myself. Okay, so this is not part of the API, Web API pipeline authentication. This is done before Web API is even invoked. It's done by MVC and by ASP.NET, and actually it's done by WIF. And now I'm hitting the get method. If I look at the principal object, if I check it out, this is the this.request context.principal, and I'm in Web API right now, but I didn't add any Web API security code. I can see that the claim is actually a claims, the principle is a claims principle. The identity is Ido and Ido Flatow.net. And I can actually see the claims here. And the list of claims contains a whole bunch of claims with my small string. First name, last name, username, tenant ID from Active Directory, claims, and even a role that actually I edited manually because Active Directory doesn't provide you with roles. I edited it manually, admins, and that's why I was able to go through this restriction. Okay. If you want to check the code later, there is a custom class here that actually adds custom claims to the principle. So the first demo, I just went through MVC. MVC did the security part. Now what happens if I'm using .NET? If I'm using .NET to call my Web API service, I'm actually hitting Web API directly. I'm not going through any of the MVC code. So for that, I actually need to add some OWIN support for my Web API. So what I'm doing is, in my startup, there's a call for the OWIN configure off. When you configure a new web application using Web API with Office 365, for example, it adds similar code to what I did here. Okay, so the configure off configures the Windows Azure Active Directory bearer authentication object. This is the class with the longest name in the .NET framework. This is part of a framework called Azure Active Directory Authentication Library, or ADAL for short. And I'm specifying here another method, use Windows Azure Active Directory bearer authentication. This is basically uses OAuth against Active Directory. This is the custom claim transformation where I'm adding my admin, okay, because that's also missing here. And the only thing I need to do is install the ADAL framework in my client application. Let me just go to here. The ADAL framework gives me the option to create an authentication context. I need to provide it some information where my Active Directory is, a client ID, so it will know that an authenticated client is trying to use that application, okay, because I want to prevent other .NET applications from using my Web API. And this method will actually open a page telling me to authenticate myself against Active Directory. Once I get authenticated, I will get the token back, and the only thing I need to do is get that token and add that to the authorization header of the request that I'm using in HTTP client. Okay, so this is just the authorization header. We'll see that. We actually won't see that in Fiddler because I can't catch the localhost content. But it's just a header saying bearer and a very long key that has my token in it. If I run that, first of all, let's run that. First of all, I'll get a box saying, oops, sorry, not that. Active browser-based applications are failed complete for unknown reason. Okay, unknown reason is always good. So let's try that again. Real unknown reason. Okay, use another account. This one is not showing my image. I don't know why. I need to talk to them about that. Authenticated gets the token, sends the token to Web API. If I would have put a breakpoint in Web API, you'll see that I actually get the same claim principle. Okay, but this time it flows directly through Web API. Still not through message handlers, it's still through OWIN, but it's OWIN in front of Web API without any relation to WIF, without any relation to MVC. It's just OWIN plus Web API. Okay. If you don't want to use the OWIN middleware, you can just download the thing picture identity model, and that uses message handlers. So got the content, and that's basically it. Okay. I can do the same authorization rules. As you notice, the API controller uses just the authorized attribute. It doesn't care where it got the principal from MVC through WIF, through OAuth with Azure Active Directory and ADAL and OWIN middleware. Doesn't matter. From a message handler, it doesn't care. I use that same authorized header for 3 different authentication modules. Okay. So when we look at all those pieces together, if you really are going to build a robust back-end services for your application, you will probably want to use security. That's the first thing that we will use. You will probably want to use caching if you're using web browsers for clients. If you are going to upload content, download content, you will probably use streaming. Use that. Don't return bytecodes, please. Okay. And of course, configuring the pipeline is something that you will find yourself doing after the second week of using Web API. So just before I'm done, here are a bunch of resources for you to use. There is a great set of tutorials in the SPNet website about Web API. There's also a blog that aggregates all the Web API bloggers. I'm not there yet, but I need to talk to them. If you want to learn more about Fiddler, the tool that I've used, there is actually a great video, because I'm in it, that explains how Fiddler works and how to use it to debug web applications and other stuff. If you have some time during the flight back home or stuff like that, you can download the HTTP RFC and read it on your way back home. Okay. And if you need to contact me with any questions, my details are listed below. And of course, this slide deck and the code sample, the entire agency code, is available online at the address on top. Okay. It's case sensitive, so just watch out. Thank you very much for coming and enjoy the rest of the day. And I'm here for questions.